Hello, my name is Christopher Collins, and today I will be showing you how to use MongoDB to analyze Elon Musk's tweets. So, the first thing that we'll need to do is download the dataset. So, I download the dataset here. It's provided by MongoDB. There's a zip file. I just quickly go into this zip file and open that. There's a CSV file. So I'm going to cut this CSV file and put it in my C directory in a folder called Data Files. Now, I'm just going to quickly show you inside the CSV file. Now, the CSV file has loaded, and along the top you can see the column names. If you pay attention to these, some of these will look familiar when we look at them in MongoDB later. For example, this one, the photos one, and then there are all sorts of other fields here. One where usernames are mentioned. So I'll close that. To load the CSV in Mongo, we have to go into Windows Command Prompt. So what I need to do, go to Command, Prompt, and let's close this. Now you need to run a line of code just to navigate to the right directory in Command Prompt. So I change directory to the Mongo folder, to tools, and we'll be running the Mongo import tool. Pulling in the CSV file under the name Elon Musk as the database name and tweets as the table name, or it's called the collections in Mongo. We import it as a CSV data type. Headline means header row. Mongo will recognize the top row as a header row. So it's imported that successfully. Run 9,256 documents. I'll just close that. And the next thing is to load the Mongo shell. So the way that we do that is go to C, and on a Windows computer it will be normally in the Programs file. MongoDB, under Server, go with the later file number in the bin directory, and then you click on this exe file called MongoD. Double click it. It will load very briefly and close again, and then finally click on mongo.exe. What I'm going to do is I'm just going to close down that navigator here, minimize this, and put that this side over here, and pick up this one, and we'll get a side by side view. Just double click there. Just clear the screen. I write show databases. You can now see that the Elon Musk database is imported, and I write show collections. Sorry, there was a step before that. I have to write use Elon Musk to switch to the database, then write show collections, and it shows me the table name, tweets, and what I can then do is I can run some queries on that. So if I want to have a look at the contents, I can do dbtweets.write, but that's kind of a very busy format. So if I write dbtweets.pretty, the prettiest format, and there you'll begin to recognize some of the column headers which are on the CSV file and the field names. And if we want to count how many documents there are in the collection, I just write count, and it shows 9,286. Moving on to some more queries. If you want to just display certain columns, you can do a find, an extension of the find command, where you indicate by either a 1 or a 0 wherever you want the column name to be shown. So ID is always shown by default, so you put a 0 to make sure that it's hidden, and you just include the names of the columns you want to show with 1. So this shows all the tweet fields and all the retweets count numbers. But you might want to see that in a sorted view. So here I've got it in red. You extend that command using sort, and then you put -1 if you want it in ascending order. So I run that. You see it's got the tweet field, and in ascending order it's got the largest one at the top with 384,289 retweets. So that was a really popular tweet. You might want to use this display with a specific query. So here I've used a query to get only those records with 5,592 in the likes count. I just want to show the likes count column and the tweet column and hide the ID column again. Make sure that you copy that in. Setup, and it picks up a document with exactly 5,592 likes. So in this query I've limited the number of fields that it shows, and I've shown only ones with an exact like count of 5,592. So moving on to something a bit more advanced. You might want to query more than one column at a time, so you'd have to use the AND operator. So in this one I'll put AND not equal to. So I want photos that are not blank and mentions which are not blank in the pretty format. going to run that, and as we look down, it's got photos aren't blank. See this photo fields here, and the mentions aren't blank. Now that's done in pretty format. Of course, you can do the same in the normal format too. So I just copy that. So that's a count. So you can run it, same query, but as a count. So that shows 131 records have a photo and a mention. Say you want to find a particular word, like rocket. You can find all the documents that contain a tweet field with a particular word. When I run that, you see it's picked up rocket and rocket, so that's because I've used regex pattern, so anything that follows that pattern of words, it will pick up the tweet field. Another way to search by keyword is to create an index field. So it says an index has been created, and then rather than searching the tweet field, we search text. And it is able to search for posts containing rocket that way. You might want to run that again, but put it in pretty format. So here you go, in pretty format it's easy to see rocket. So now if you want to count all the posts that contain rocket, and do that. And it shows 155 documents. Now, we might want to check for capital letters because MongoDB is case sensitive. So I copy with the pattern with capital R, and see it's got 30 documents retained. So in total there are 185, which either have rocket with a lower R or rocket with a big R. So one way to find the 185 would be to do an OR query. So copy that. Now looking for small rocket or big rocket, 185. The other way is to do it as a regex query, and I means ignore the case. So when I do this, query, that also gets 185. But it's a bit lengthy to remember to write regex every time. You can just write tweet and slash rocket backslash and the I. You don't have to put a regex. So I do that. That also gets the count of 185 as well. Now, MongoDB has comparison operators. So you've got greater than or equal to, less than or less than equal to, or equal. So I'm just going to run through these very quickly just to show you that these highlighted ones work. So we're looking for tweet count replies that's greater than 10,000. Copy. Got 50. Do the count of number of tweets. I call them tweets, but correctly, because they're Mongo database records, I should be calling them documents, which have a retweets count greater than 0, so that's obviously 1 and above, or less than 4. That's 41 there. Then, if I do greater than or equal to 1, so remember this one was 41, is less than 4, so that meant it was 1, 2, or 3. And I've got greater than equal to 1 or less than equal to 3. So it's still 1, 2, 3, which I'll have to apply this. So I'll be expected to see 41. So we'll try again. Number of tweets. Okay. The next one that we'll do, which is just really a point of interest to me, is Elon Musk is very popular on Twitter. Were there any of his tweets that were never retweeted? So have a look for count all retweets which were 0. Now just remember, he's sent over 9,286 tweets, but only 4 of those were retweeted. That's quite interesting. So the next thing is I'm going to show you an inquiry. Now I want to find the tweets which have a likes count of either 1,459 or 2243 or 3135. So copy that. Again, it's quite hard to read in this format, so I'll just make that pretty. And we'll have a look. Its likes count of 1,459, 2242 or 3135, so there is one that has that exact amount of likes. Now, if we want to see that in a more readable format, remember what I was showing you earlier? The likes count 1, tweet ID 1, ID 0, so we can more easily see what that relates to. So, yeah, it sets a very random tweet there with an exact number of likes, 1,459. Another tweet there with 2,242 likes. It's much easier to be able to read it like this than have to read all of those records at once and try and find it. So another thing is you can do the reverse of that. Say you want to look at certain documents that don't contain words. So I want to look at documents but I don't want to contain any of these words or word patterns. I'll copy that. Press enter. And let's have a look at the first one. Thank goodness for modern medicine! Exclamation mark. It doesn't have to, is the, he, of, or, a. So, the next thing that we'll have a look at is we'll do a sort exercise, sorting retweets count in ascending order. Just clear the screen, run that again. So if I scroll to the top here and have a look at the retweets count, this is the most retweeted tweet. And if we want to get the maximum value of likes, we can do a sort, but just limit it to one result, so that gives you the result with the maximum number of likes. Tweet which had the maximum number of likes, we look at the likes count for this, it had 1,682,551 likes. That was when Elon Musk tweeted the coronavirus panic is done. That's before it became a big thing, so that was March 2020. That's the American date format. And if you want to do a sort with the other fields removed so that you're not having to look at all of that, you can, again, like I've shown you before, put likes count 1, tweet 1, just to show the tweet and the like fields. So that just shows those two relevant columns there. Now, this query here is really just to show you the potential of MongoDB. I had to get help creating this one, so kind of due credit to Stack Overflow. I was just interested in it for research. So this gets the top 100 words used by Elon Musk in his tweets. So I'll copy that. It picks up fairly common words, so to the A is of. So if you're getting really advanced with Mongo, you would need to combine this query with a not-in query so that you would eliminate some of those common phrases and get some more interesting content that you can include in these tweets. So here is fun, what we call an aggregate query that groups the hashtags. So first we'll just do a grouping. what that should do is bring up anything that's unique. So when I run that, it shows you the different kinds of hashtag results that you would find looking down the columns. What it doesn't tell you is how many times those combinations have been used. So what we do is do this is one that groups by the count of dates. Before I show you that one, this is a group count of how it's the hashtags that have been used. So this particular hashtag has been used once. Armageddon, but this one, Falcon Heavy, has been used 3 times. And out of the 3 times that it's been used, the average amount of times it has been retweeted is 6,960 times. And then you can do other analysis by date. That shows a date on the left side, and it shows you the number of tweets sent on each date. A bit more exploration is needed of Mongo database shell to be able to write other queries that kind of sort that and give us more information. So I've done one here that gets the dates that Elon Musk sent more than 4 tweets. And it brings up these dates. We can do some aggregates on tweets that contain certain words. So we've already done the create index before, and it matches the text. So it searches the text for the word Tesla and does the sum of the likes count. So when I run that, basically out of all of the tweets that have used the word Tesla, there's been a total of, looks to me like over 20 million likes. And then there's another special aggregate which can bring up the most relevant Tesla tweets. MongoDB has this own scoring system, so if we want to look at really relevant tweet fields about Tesla, we run the scoring. So it considers this one as very relevant. New Tesla referral program, and then it's referring to Tesla's computers, Tesla bioweapons, Tesla Solar City shares, so they're quite good. And then if you want to have a look at the less relevant ones, I'm not sure how it scores it, but there does seem to be a bit of a different writing style between these ones and the previous ones. The word Tesla may have been mentioned 2 or 3 times. This one is kind of less prominent in the phrase, so that's why it's scored lower. Now, MongoDB, just like Access, has its substring and concatenation options. So I run this, it gets the first 3 letters of the tweet field. Now, I couldn't tell you why someone would want to do that, but I'm just demonstrating that you can do that as a substring. And if you want to do substring aggregation, this takes 2 columns and performs the substring on each of them. So I've got an abbreviated tweet and an abbreviated link. So there's the abbreviated tweet and there's the abbreviated link. Now you can also do a mixture of substrings and concatenation. So it's used a substring of tweet and concatenated it onto a link. And then moving down, you can use the aggregation to get the maximum value. So you might remember when we were doing simple queries, we got the maximum value by doing an ascending sort. But another way is just get the maximum value rather than using a sort. So press enter. So most like tweet, that's one of the maximum likes, had 1,682,521 likes. And then you can use aggregation to get the sum of all likes. So across 5 years, how many likes did Elon Musk get in total? Well, it's quite phenomenal. He's had over 173,971,319 likes. Okay. Now let's take 3 random records from the collection. So do that with the sample, and you can kind of see 1, 2, 3 there, and you can criticify them if you want to sort of look at more detail. So another thing which is useful in any query language is being able to do conditional statements. So if it satisfies one condition, you give one message. If it satisfies another condition or doesn't meet the first condition, you then give another message. So this one, I'm analysing the posts which have a likes count of greater than or equal to 1,000. So if it's not greater than or equal to 1,000 likes, then I send the message less than 1,000 likes. Otherwise I send a message 1,000 likes or more. So this one shows 1,000 likes or more, and these ones so far show 1000 likes. Scrolling along, you might see one here which has less than 1000 likes. Okay. Sometimes you might want to look at a query like that, but do it by certain words. So, contains words or doesn't contain words. Combine it with an all query. So, this one contains words that I'm looking for, and this one here doesn't contain the words. So, if for any reason, like I did, you're trying to use the aggregation out and it doesn't work, you can prefix any query with a new collection name, brackets, close brackets, and write save, or the collection name and insert it, and open brackets, close brackets. So if I run this a second, it says a right result inserted 1. So that was under test. Next one, insert, center, and same result again. So I now go to show collections. It shows the original tweets collection, and the test which was created by save, and test 2 which was created by insert. So I went db.test, find, it would show me the results of the query in there. So next, we have some queries here on adding records. So say I want to add one record to the database. Let's go copy and use insert one command. Now, it shows me that that has been inserted. But the insert one command isn't just about adding one field to one document. You can insert many fields into one document. So if I just bring up my notepad. Yeah. These. Put that into MongoDB and press enter. It acknowledges that that's been inserted as well. So Another way to insert multiple records is insert many. So this is inserting many records, but with just a few fields. So copy, press enter, and it's acknowledged that those IDs have gone in. And another way is, if you're not inserting fields, you can also update fields. So say I find this record. It has a likes count exactly equal to 5,592. So maybe you should design flag of Mars likes count 5,592. I can update that to say truly awesome tweet. So I go copy. It says it's modified 1. And the next thing that I do is I copy that to find that again. So instead of saying it back to flag on Mars, it's saying truly awesome tweet. Now, one thing is, if you want to update many of them, you can set a condition. So anything with likes count between greater than equal to 7,000 or less than equal to 8,000, I'll put in a new analysis field and call it fairly popular tweets. So that's not updating any existing field, it's creating a new field, new analysis field. So I'll run that. It's under the 173 records, and if I want to check the result of that, I'll just copy that. Let's have a look. So, in the new analysis field for each of these records here, it's just written the phrase fairly popular tweets. Now, MongoDB also has something called replace. So replace one if you only want to replace one record. So say I want to replace the tweet called, where he's used the word cute. Just change the text to replacement tweet. The new table story tweets counts as 900. First, I'll just show you this. A tweet there called cute, and that's the top one. So when I run this code, apologies that it's modified one. Scroll to the top, and you'll see that that one has been replaced. So the tweet field says replacement tweet, and the tweets count field says 900. And because I didn't replace all of the other fields, they are now gone. The other thing is a method called upsert. So say you wanted to replace something if it was there, but you couldn't remember if you deleted it. So you try to replace a tweet that doesn't exist yet. You can use the upsert. So it will look for it, and if it doesn't find it, it will create a new record anyway. That indicates that it's added record. And now, finally, we shall have a look at update many. So, any tweets which have a likes count less than 2 or equal to 100, I'm going to set the tweet field to say not at all interesting. It's modified 78 records, so let's have a look. Okay, there it's picking up the likes count and the replacement tweet which I put there. Now, the next part is deleting them from Mongo. So we now, rather than updating them, we want to remove them completely. So anything with less than or equal to 100 likes, we're going to delete from the database. So, first one, I'll put true, but limits it to just 1. So it says removed 1. If I don't put true there, it will remove all of them. So, So let's remove 77, and let's see if we can find any on the system now. Press enter, nothing comes up. So the next part of the assignment is looking at MongoDB Compass.